Okay,
Yes,
now
yes.
I think you can see the screen, my screen in full
Yes,
screen.
Haris.
Okay,
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 Haris.
thank you,
Yeah.
thank you. So, we'll provide you a brief update on the technical details and the overall system architecture of aerOS Meta Operating System. I am Harilaos Koumaras, I'm the technical manager, and also Vasilis Pitsilis from Dimokritos is the implementation manager, and we are closely collaborating in realizing aerOS. First of all, we start with the problem statement, why we need a Meta Operating System for the IoT Edge Cloud Continuum. And the emphasis is put on the necessity for IoT, because it's not just an edge cloud continuum, but it is an IoT edge cloud continuum. And the need has been identified from the fact that IoT is considered as a very important enabler for both cloud and edge computing, because IoT is actually the source and the generator of a vast amount of data, which these data are further analyzed, processed, and feed in AI models, etc., that exist and live and are deployed either in the edge or in a central cloud. So somehow there is an interconnection between these three entities in terms of the data utilization and data exploitation. However, from a developer's view perspective, these three nodes are currently quite distributed and differentiated. So there are many challenges that the developer has to deal with when builds an application that has to retrieve the data from IoT gateway, to discover an IoT service, to feed the data in a trained AI model, and further or more to take additional decisions based on the results of the AI model. So currently we have custom-made IoT data-driven applications, custom-made to each IoT sensor, to each IoT gateway. We have very limited reusability of these applications because we have runtime limitations. Then the extensibility of them, of these IoT applications, is again very limited due to interoperability limitations. An application that has been built for a specific IoT gateway, IoT sensor, cloud environment is not usually extendable to another system, to another sensor. Then the IoT applications usually are not very distributed. They are monolithic, they are built once, and they have very resource discoverability limitations. So it's not easy usually to transfer the application from one domain to another domain, and etc. The service placement today is very trivial. Usually we don't have any orchestration of the services. And of course, the AI functions, AI models that are used are usually embedded and not easily transferable in another environment. So we have a very static and system-specific approach from a development perspective. And this, of course, limits the development, limits the performance, limits the innovation. The aerOS vision and the Meta Operating System vision is to create a unified environment. So to have the aerOS Meta Operating System to unify all the IoT hardware, IoT sensors, IoT gateways, and expose the IoT services in a unified way, on top of which the data can be discoverable, can be exploitable, and can be used as input for other services, AI models, etc. So we want to, through the Meta Operating System, to create a unified ecosystem, a unified application management, a unified execution environment and runtime environment, a unified exposure network and compute resources and capabilities, a unified exposure of the IoT services themselves, and the unified integration of all the AI applications or other types of applications that can run on top of this unified runtime system. So as you understand, this unified environment can facilitate the development of new services, since any new service, any new application will not be built specifically for one application, one service, but will be built once for the Meta operating system, abstracting all the differentiation, all the specific technical restrictions that an IoT and cloud system may have. Let me give now the floor to Vasilis to present further on the layered approach. And Vasilis, I will change the slides for you.
I can share.
Thank you. Hi, guys. May I ask to be brief in the presentation so that we can give floor early to the members, because some of them will need to leave earlier. So thank you very much.
Okay, yes, very briefly. So let me share, Haris, my screen so I can...
okay.
Yes, we can do it faster this way, more easily. Okay, I hope you can see my screen, and now this is the presentation. Okay, so after what Haris said for the need to deploy a Meta operating system that can unify and integrate all the IoT application needs from edge to cloud, in order to provide such an ecosystem, aerOS has followed a layered approach, and in fact, it employs the aerOS fabrics. There are three main fabrics: the network and compute fabric, the service fabric, and the data fabric. They are all interconnect, interoperate to provide this support. So first of all, what is the network and compute fabric? This is the most top-down, let's say, placed fabric that, in fact, it unifies all the heterogeneous network and compute resources among all the administrative located domains. So have legacy, as Carlos said, the infrastructure used in several places, pilots, but beyond pilots in the industry. We have virtualized resources or physical resources, legacy resources, new resources, and they should all be exposed as a pool of resources, network and compute resources that can be used to serve and to host IoT applications across the continuum, no matter where they are located or no matter what technology they are using. So the first, the network compute fabric that unifies all this infrastructure and exposes as a pool that the service fabric then subsequently can use. Let me proceed. The service fabric can use this underlying network compute fabric and expose it unified as an underlying network layer that can support the deployment of services. So the service fabric has this twofold goal. One hand, this to expose all the underlying network compute fabric that can host applications and expose all the capabilities, based on the capabilities exposed, to provide the most appropriate each time that can support in the most appropriate location the intended IoT application. And then the other goal of the service fabric is to provide the lifecycle management of the IoT applications deployed across the continuum. So a service might be broken in more than one service component, deployed in several distinct aerOS domains, but they all should be lifecycle managed, monitored, take actions for failures or to enhancements or whatever. And this lifecycle management from day 0 to day 2, all the actions are taken from this service fabric. And now serving both is the data fabric. The data fabric has the goal to provide the unified and integrated ecosystem on top, leveraging information of both the network and compute fabric and the service fabric. So from the network and compute fabric, it exposes all the available virtualization resources, their capabilities, their availabilities, all their intrinsic features that can be used, and when selecting where to place its IoT service. On top of this, it can also federate across the domains the available and deployed IoT services. Where are they deployed? What are the ports, the networking capabilities, their application capabilities? What are they using? And on top of this, these running services are producing data, which again are part of the data fabric to be used and federated across all the domains. So we can say that it provides a seamless and consistent experience for ubiquitously accessing and managing data, services, and resources across the continuum. No matter where they are placed, they are exposed in a common way, and they can be used for decisions regarding the management of the services, the use of the most appropriate resources, the location, the placement, and all the capabilities that are needed in order to run an IoT application. In order to achieve this, so the main functional unit is the aerOS domain that integrates. So it's the unit that exposes all these capabilities. The domains are connected among them with a service called Federator, we'll see in a moment, that makes possible the fusion of information regarding the available resources, capabilities, the services deployed, and the data produced by the IoT services. Let me say that each domain at least integrates one infrastructure element. The infrastructure, one or more. The infrastructure element is the abstraction of aerOS of all virtualized or physical computing resources, either legacy ones, new ones, whatever kind. So the infrastructure element are, let's say, the integration of physical or virtual resources in an abstract way that can be used from aerOS domain to deploy and host services that are needed. So all this information, what is integrated in each domain, are federated based on this service, the federator. And this provides a sub-layer, a substrate, let's say, for the aerOS verticals to deploy their applications on one domain, the other domain, or distributed in both domains. So the overall image, let's say, is that we have a pool of domains, a set of domains, a lot of domains, each one of them integrating many different technologies of computing and technical resources, new, legacy, virtualized, containerized, physical, whatever. They are abstracted within the domain, and on top of all these infrastructure elements, the aerOS services are deployed the core services, which can support the distribution of this information, the reuse of this information across the continuum in order to make the proper decisions. One of these domains is called the entry point domain. It's not different from the others. It has just two more capabilities, which are the GUI, the entry point for the user to interact with all this, and let's say the provision of security information to securely integrate and use all the resources based on the users and their capabilities and their permissions. So what is done is that we have a source of underlying resources, computing resources, IoT technology integrating in these resources. They are all commonly exposed and federated across all the domains. And the result is to have a network compute fabric, we say a layer that exposes a pool of resources. They are used to deploy the IoT services. And we see that each user can deploy multiple services, and based on certain criteria, they are deployed, distributed in one domain, the other domain, or distributed across many domains. So all these decisions are taken based on this information the data fabric uses and federates across the domains, and AI algorithms that make the orchestration of these applications. Again, here we see that the entry point domain provides the GUI guided support for an IoT developer to supervise their domains, the integrated resources, the IoT service deployed, and to submit requests for deployment of services. Now, in order to achieve this, each domain we see integrates these basic aerOS services. We see at the more layer top-down layer, we have the infrastructure elements. They're abstracted. It's the resources, the computing resources, abstracted as infrastructure elements and exposed as a pool of resources under the aerOS network compute fabric. Now, the service fabric that operates this and manages and undertakes the distribution of the IoT applications has a lot of aerOS core services, but the most prominent ones, beyond all the needed security, it's out of the discussion, this is a very serious take into account. It has two basic features, the most prominent, which is the federator and the orchestration. Now, the federator is what makes possible to use information in one domain of all infrastructure elements and this to be at demand on real time used by other domains to make the decisions. And who makes the decision? The orchestration engine. The orchestration engine is again an integral part within each domain, and it can make decisions for placement of services across all the domains because it has all this federated information. Now, what is important here is that we have followed the separation of concerns regarding the low level, the decision where to place each service and how to enforce this decision. So on the upper layer, we have all the restrictions of the IoT developer and all the available capabilities within this domain and the other domain. Based on AI support, the orchestrator can make the decision and it then submits this decision for enforcement in the low-level orchestrator. The low-level orchestrator can talk to different kinds of resources. It's an extendable technology. It can integrate and extend at any time with more integrated resources. So federator and orchestration provide together a federated orchestration over the continuum, taking into account all the information distributed across the continuum. So these are the most basic aerOS feature, core aerOS services integrated within each domain. And if we want to see how these layer one top of the other, we have different hardwares, different operating systems, hypervisors, containers, physical resources, virtual resources. On top of them, aerOS runtime abstracts these underlying resources integrated. It provides a common runtime environment. It's very important because this way all the applications can run on each domain and can migrate from domain to the other based on certain criteria or preferences or failures. The basic aerOS basic services, among which the orchestrator and the federator can make use and integrate all domains to be exposed as a common pool of resources. And on top of this, we have some more aerOS auxiliary services which make possible to take advantage of extra features based on each IoT vertical case. And on top of this, IoT user services are deployed as IoT applications. And the overall architecture, let's say, abstraction, reference architecture, we have the separate domains, they are federated across them, they abstract different infrastructure resources, computational resources, network resources, infrastructure elements. We build the fabrics on top of this, the orchestrator, which talks to the different resources, the high level for the decisions. One high level orchestrator can submit requests to a remote domain based on the decision it makes, because it knows it has all the knowledge of the continuum. And this has as a result to achieve an integration, unified integration of AI applications, as Harry said, a unified exposure of these IoT services, exposure of all the network and compute capabilities under a common API, let's say, and management way, and achieve a common execution environment when services can be deployed in each domain, migrated on demand based on the circumstances, and have a common application management for all this continuum across the cloud edge ecosystem. So we have at the end a unified IoT edge cloud